whatever. We have to get loaded. There's whole stuff. I have there. So that's the password the whole game. And that's all I can. Sure. Chat. Yeah, we've read each other. There's Hans. Okay. Thanks. Yeah. Okay.
Okay. Setting up a few notes to cue the discussion on Python and classes and Python's class model. Are we ready to engage or sorry?
Yes, we're ready to engage.
So last time that we met virtually or physically, I started presenting Python's mechanisms for writing and using classes. And by discussing the distinction between instance methods, static methods, and class methods. And so that distinction for when I first tried to figure it out was fairly subtle. And the class method distinction is really never seen before in any languages, and it took me a while to latch on to what was going on there. I thought I'd go back to this one more time and have created some notes to try to explain why the distinction among the three. The first part of the distinction, for anybody who's worked for some time with classes, should be familiar. And if you have worked for some time with classes, it took me a while to figure this out, and it also took me a while to figure out a reasonable way of explaining what was going on. In object language, when you have a class, the standard practice with class is to split logic between the proper and the uses of the class. And I believe a way of trying to save space and really make the programs more efficient. And that's part of the issue. The other part of the issue is that, well, is everything, whenever you have sharing in any sort of computing context, it's just about always there for reasons of efficiency. Whenever you share things, you always complicate the logic, because especially if the things that are getting shared are writable. Because if you have two entities sharing the variable, sharing the file, you have a possibility of the entity stepping on one another's toes. But still, sometimes that's where it makes sense for the two entities to have their own copy. So Python, when you create bar and own off instances using the class constructor, what happens with the same with other O languages, in different instances, in Python you would say something like That's called bar, and the convention in Python is you capitalize classes. Bar would have some sort of a constructor. You say something like instance 1 equals bar of whatever the constructors are, and then now you have an instance of bar. One bar instance 2, and where'd my go? Okay, have a second instance of this bar, and the instances have some stuff private to 1 and private to 2, but they have some stuff that's shared. Okay, rule, different instances of a common class in every OO language that I've seen will always share methods. The code, as a rule, is because there's absolutely no sense in having each instance having its own private code, because code doesn't change. Now, I believe some new languages have even ended this old practice. I don't know Ruby. Well, I started working with Ruby this past summer, but I believe that in Ruby, you take an instance of a class and hotwire a particular instance of a class so you change a method. So, for example, if you had a class called circle class and your method called get from circumference and get area from diameter, or get circumference, you could, in a Bizarro circle world, take your instance of a circle and hotwire the area method so it used some maybe spherical trigonometry formula instead of a Euclidean geometry formula to compute the circle's area. But methods in most languages that you'll see are shared. In most languages that you'll see, including Python, variable data is specific to the instance. You, however, declare certain variables, certain items to be what Python calls static. You all have the ability to do static in C++, so I don't know about Java or C#. I haven't worked with them enough. Static item is local to the class. And I have examples I like to have you run in a bit. I had you run those examples 2 weeks ago. I'll have you rerun them. With the static value, with the data in the class object rather than local to the instances. One changes the value, all instances see the change. In effect, this variable works like a classic globally scoped variable in Python, Pascal, or in C, or a number of languages where the scope, instead of being out at the level of the whole file, is specific to the class. Okay. Global scope or static scoping since the days of David Parnas, the first person who started to figure out how to make programs maintainable way back around 1970. Global is regarded as very bad for maintainability due to the difficulty of figuring out what entity changed what value. If you go back and you try to ask why a code has gone wrong. For reason, I restrict statics to constants. For example, if you circle class and you value pi that you're used to compute across all your instances, use 3.14, 3.142, 3.1416, 3.14159, depending on how much precision you think is necessary to get your work done. All the classes share the value of this constant pi. And sharing is not a bad thing because the class instances are probably not messing with pi. Okay. So far, the difference between statics being located in class objects and variables being located in the cloned off instantiations of the class should be fairly standard. The class method stuff is not. Before I go into class methods, does anybody have any questions about the differences between instance variables and static variables? You're with us today, right?
Yeah, can you hear me?
Okay, I can. I asked you to break in with any questions from anybody who's in 206, if anybody has any. Is that fair?
Yeah, that's fair. We have no questions right now.
Okay. Python gives you a feature called class method, which I've never seen in any language. I see as marginally useful, but it's there for completeness. And as I thought about it, I think it's there for a good reason. Okay? If you have a class instance, class, if I use a variable, inherit limits what variables I can see. So let's, for instance, access a static called myvar. I reference and works like standard object-oriented languages. If you reference a non-local and the non-local is inherited, resolution protocol goes up through the class chain. So, instance 1, reference myvar, you go through the class chain, you get .myvar. Because and statics do not allow you to qualify inheritance is working out, this declaration of bar.myvar hides actions of myvar in bar subclasses. So with static methods and instance methods, bar 1 access foo.myvar or uberfoo.myvar. With methods and access that are up the chain. If you see that bar instance is an instance of uberfoo, then, and you'll see in a minute, any sort of method that class method that works on class data would work on uberfoo's instance of myvar rather than bar's instance of myvar. So a couple of examples. I'm actually that hit data items in points on an inheritance chain using this class method mechanism. And what people to do is to, let's see, drop to I'll tell you what, since the end of any sort of class, people to be overloaded and rushed. Let's begin with writing lines 2381 through 2015. And one statement you'd execute in this, in your my notes. I'll put that statement there in the final version. To run, first of all, the examples 2385 through 2416 is a bit of a refresher. Actually, start with 2381. This whole idea, this notion of class identity of inheritance. Ryan, we're done with that. If people have any questions, get back to me and we'll go on to 2420. Yeah.
We're ready. Oh,
Okay, so next round, just to walk down through the basic points again. Even classes will something about the characteristics of entity in a language. When I try to learn a language, I try to start with nothing and figure out how nothing works. So this is nothing class. Again, Python. And next, class is an object like anything else. The identity of every object in Python, from what I can tell, is its memory address. You say ID, you get back probably a location somewhere in the Python interpreter. If you do not specify a class's base class, that base is object, the class of all classes. Directory on an object will get you that object's attributes. Class object classing adds a couple of additional methods that, for reasons that I don't quite understand, don't show up in the object, in the object. Types. Class are types. You define a class, you define a new type. For instance, one here is a type of which is of the main interpreter in Python. The different objects each have a distinct identity, and because they have different identities, they are not the same object. So the thing to do is to have people, once again, 2490 through 2015, and those define as instance methods, class attributes, and static method. So I'll review this. Again, Ryan, tell me when people are ready, and I'll do a quick review of what's going on here.
You said to 2015?
2020 to 2515. Essentially, highlighted area in notes that define my class.
All right.
Okay. So again, Python convention. If you method in C#, Java, A++, data, function that show up in a class method's signature. Killer works magic for you. And whenever you need an instance method, the permission the language say that references to variables are to local state. Compiler does that all for you. In Python, you pass the instance as the parameter of instance method. And by convention, every Python program I've seen use self as the name of the instance. Though, again, it could be Phil or Ryan or Bobby or whatever. Static methods and class methods work a little differently. Static only do not take a self parameter. Static methods could have no parameter whatsoever. In order to get static method to work, you have to apply some pre-processing and post-processing. And the static method functional, which is a decorator, and I'll show that a little later. Instead, a static method as a static method seems to work this way. Methods are similar, except class methods also take the class that the current class object as parameter. So, having said something about what all these things are doing, let people to run lines 26 through 25, 53. Let's do a simple case first. The idea that, once again, types are classes and that instance values when set and accessed affect instances. But on line 2553, and again, please, Ryan, tell me when people are ready to proceed. Forgot. We also need line 2518. My fault.
We're ready, Phil.
Okay. Again, Python has a feature that can be useful at times, never seen before in any other language, where instead of saying instance dot method, you can say class and pass the instance as a first parameter. Okay? Not fluff by these highlight examples. Give particular idiom a little thought before you run, because I have done some coding where this can be helpful. Let's go on to lines 2550 through line 2568.
Okay, Phil, we're ready.
So, real quick, okay, who shall you? Okay, so what's going on in this okay. Because we have multiple instances of my class and my subclass, all in one shared value, and the way to that shared value, stat value, is what all the other instances see, regardless of where those instances are hitting on the chain. So the third example should make the difference between class values and values, where we have a variable called foo. I'd like people to run line 2572 through line 2584.
Hey, Phil?
Okay?
Action.
Yes.
So these functions, these set, class, attribute, foo functions, are they built in?
I think they describing on is that income ability to associate property with any object, any real and writable object. Classes of objects, like animals, you have some built-in policies for reserving references to non-local attributes. Policies tend to take names, identifiers, and locate those identifiers in a particular place, all in your class hierarchies, all things being equal. You are getting with the class methods a different set of policies for governing how you get at the use of an object in a class hierarchy. With methods, you're going up through the hierarchy with the logic that's bolted onto your function is function to a particular class rather than resolving names by going up through the hierarchy. I'm answering your question as I am, because that there is a mechanism, particular mechanism that's built into Python, because every Python object is simply things. You can think of Python as things with slots. Rather, what you are getting is a different that gives precise control of what lot you're accessing. Is that an understandable explanation?
Yeah. Yeah, that's an understanding. Thank you.
No, it's an excellent question. I appreciate raising it because this distinction between class methods and static methods confused the heck out of me. I've been using Python for a number of years and really never understood it until the last time I taught Python in an academic setting at ETSU, which was back, oh my goodness, 2 falls ago now. And I said, I have to know what's going on because the libraries and Python documentation is not really making this clear to me. And once again, there is no substitute learning a language for constructing simple examples and trying to simple examples to flesh out. Sometimes, if you're fortunate, a lot of times if you're fortunate, you can get an author who gives you a decent explanation of the subtleties of what a language is giving you. But oftentimes you can't. And to repeat said from time to time over the course of these talks, most notes out of my struggles to understand what I was reading. So it really instructs simple examples of and differences between things. Okay. Another sermon. Let me go on to some syntactically easier way of setting up static methods in class methods. So, I want to set up static methods. Do you want class-wide constants?
It's
okay.
Phil?
Yeah.
Yes?
Dwayne has a question.
Okay, Dwayne, fire away, please.
Yeah, so I was, you hear that Python is like a language things together, and I don't quite know what that means. Could you elaborate on that?
Mike's Python and C++, and I've written various programs in both languages. I wrote a 12,000 line Python program back in 2003, basically a compiler for a markup language, which was a big, big project. I've all students in my operating system class put together, goes back when, again, 10 years when I was teaching our distributed OS class, put together teams, Python codes that communicated at work and create a virtual view of directories on related machines. So you could do things like put Python clients on 4 machines, have a front end on machine, use that and say, view everything in directory foo, and then would call everything across the 4 back directories and make it look as if you had one single directory instead of 4 separate directories on 4 machines. And you could delete and such. So that used to be one of my projects. A product I just described to you in distributed operating systems was simple. Well, it was reasonable, it was far more simple than it's been in which like C++, because Python gives you a virtual machine as to work with. And Java, Python also interpreted. Java with C++ I find to be a headache to work with. C# I find to be a headache to work with for small in that in order to get any sort of feedback. Logic works. You have to have the stuff. Always takes time. With part typing coding, you start trying things start working. However, when I wrote my 12,000 line markup language compiler, what I discovered was that our more at simple things that I never realized that I was. And that realization came in part because I lost the compiler and the checks that with a language like C++ or Java or C. Catch spelling errors for you. A compiler will catch your mistakes if you try to insert a list into an associative array object. We'll throw it out. The only time I find out that you have a type error in Python, except for the low-level expressions, is when you run your code. And writing my compiler, what I found was that my test suite was working best for every line of code that I wrote. So a 1,000-line program, I ended up with 12,000 tests. If I was this, if I had a 5,000-line program, I ended up with 5,000 tests. And that happened to me. But how to do metaprogramming and cut the size of my compiler in half, my tests went away. But I still had this test bank of 6,000 or so tests. And what I found was that I really needed those 6,000 or so tests because in a couple of cases where I went to change some of my logic, there was a bug that I introduced in code that just one of those that broke just one of those tests. So, a $10 explanation, 10-cent question. I apologize for going at length, but my own experience has been that Python is terrific for writing programs, start getting into more industrial frame code, bigger programs, stuff that you want to have debugged before you put out on the floor thoroughly. Compile things that interpreters just don't. A fair answer to your question. I cannot hear you. Sorry. I see you. It's a Beatles song. Your lips are moving, but I cannot hear.
Okay.
Yes, I can.
Okay. Yeah, I was just gonna ask, like, let's just say if, I guess hypothetically, all of you assistants was working on one project, and an aspect of it was, just for instance, aspect of the project where we're dealing with Luster and HPSS, and then let's say Daniel, it was file transfer. Pima had a web aspect to it, so forth and so on. Each had an aspect, and we worked on different pieces of the project. And when we all did Python, is that what people mean by it's easier to glue together? Difference when you do projects, like when we have together in one big project to cohesive and work.
People may think when they talk about gluing together, I gave you a one take on the idea of gluing together. Another full view is that it is like what I said about the distributed system. If you want, then Python is flexible enough to allow you to use Python between cases between the components, in part because it has a reasonably portable virtual machine that you draw Python on different platforms, and those platforms features in Python have APIs that allow Python to act with C+ and Java off the top of the head. Okay. Internal language. I've put together a pet project plan. The initiative that Lonnie and Bobby had asked me to work on. And in the process of revising that plan. My plan consists of 9,100 tasks. I have a Microsoft project file that has 9,100 tasks. About 2,500 hours worth of work without any additional slack. I did some statistics on that one. Less than the project is coding. 3/5 of the project, and that's driven design. 3/5 of that project plan is to figure out what is testing. What the requirements need to be met, writing the test codes and actually doing the testing. So, asking the question, is Python a good language for doing a project? Review, based on numbers I've come up with, is a more language for doing a major project. Again, 10% of this project is just testing. 10% is just documentation. Language for doing a lot of small things. But the bottom line, this is the major language right here. Making sense. Okay, excellent questions. I hope that I've given you at least answers, even if they're not right. Questions?
Here, Phil.
Okay, so I'll go on. Okay, shorthands. We talked to decorators some weeks ago and about this initially strange and truly confusing looking syntax languages have adopted, Java, and you have something like this in C#, except instead of the @ you have this square bracket construct that you stick before methods, and the compiler kicks in and does something special for you. The notation at something is a shorthand. If something is a static method or class method, it's shorthand for flute. So what I'd like to do is have grab and this in my class where I'm using the add static method and add class method decorators to get class and static methods, and just verify that version B works as well as version A. Read the examples and okay, so there's not much magic here, but let me know when people have completed these exercises, and I will go on to the next. I want to check something. Oh, crap. That's right. Sorry. That's better.
Over here.
Okay. Okay. Section meta invocation within a class. The key is a to call method from a scope. You must prefix the method with the class name or self. So this next example self and it must to reference instance methods. I'd like to this out. Examples down the line on 2012. Ready, when people are ready, point out the syntactic conventions that this exercise is meant to illustrate.
Phil,
Sorry, I missed that.
we're ready over here.
Okay. Keep in this particular example, reemphasize the duality of self, and my method with self is the first argument. The two are equivalent methods. You always class method. There is self with a class method because self doesn't enter into self references instance data, and static methods do not reference class instances, they reference the class itself. Okay. Okay. So, and heading alert because virtualization to me is the big headaches to explain, and part because the terminology is so lousy. When I think of virtualization, virtual method calls, really what I have is what protocol does allow use for resolving and complete reference to a method. Okay. Virtualization to me is kind of like what happens in a file system. And if you want to be exact about files, you want to copy or delete or reference your files all the way back to the root directory. Unix user /fill /a/b/c. Okay. But path references get to be after a while, and because of that, system command loaders use this shortcut where runs files relative to an implicit current and first part of the path relative to the current directory. Well, you have kind of the same sort of thing going on in hierarchies. Class, super class. Some hierarchy, directory, file, hierarchy, class, going up. And then I want, if you have methods of name, define at different in the class hierarchy. If always qualifying those names, my class.foo, my class.foo, uberfoo.foo, Python gives you the ability to foo refer to a reference to a specific point in the hierarchy. Okay. And unless you have in a file system, the ability to resolve the name to a place in a hierarchy becomes class design, because when you define a superclass, you may have no idea of what classes are going to be sitting under it, or is how many subclasses are going to be sitting under the superclass. Creation allows a program to do is to run a method of foo and a superclass, and the header class, if that method is not fully qualified with respect to its own class, allow the superclass to say, instead of calling my foo here, I understand I need to call a foo somewhere below me in the hierarchy. Okay. Object-oriented language that I'm familiar with support a mechanism called virtualization, and them except for one in essentially the same way. That one exception was one of the first. C++. In order to function virtual, if you're writing C++, must declare a function to be virtual. Other C++ assumes that an fully qualified reference to a method that is defined in multiple places in a class hierarchy the current class. Engineers have come to regard that particular C++'s way of handling the world as a mistake. Probably like C#, that if you don't qualify the name of a method and you're running a method within a class, then you really want to put that method name relative to the caller, relative to up the hierarchy, and show the examples to illustrate that particular point. I like people to run examples 27 48 through 2771. Look at it, see what you see. This was a little subtle, more than a little, actually. We're studying for a minute and get the people have right. This is worth studying for a minute because it shows you how to exploit virtualization and how to explicitly avoid it if you wish to.
So,
So I am here.
okay, we're ready here.
The key point in this example, invoke self. Self is to the set of events that are associated with the caller class, here my subclass. Invokes self since value. Self is an instance of my subclass. Set value is invoking this particular method called set instance value. Here, my class is not self. Explicit expressly requests the version of the method that's with my class. And that second call, I was set from class rather than being set from my class. And that the new way of invoking an instance method, self dot as self or equivalent. This is one place where you need to invoke, use the myClass.self convention if you want to bypass virtualization, if you want to turn virtualization off, if you want the superclass's version of the method to be invoked rather than the subclass. Is clear.
They're over here.
Okay. Okay. More subtleties. The type like C++, Java and C Sharp to multiple inheritance. And what you have multiple inheritance to ability to set defined and class B, A, class C is from both A and B. Okay? Now, the Java designers and C# language designers after them set multiple inheritance potentially dangerous and confusing construct, and she included in a programming language that any mere mortal can use. Well, it's a dangerous construct. You can shoot yourself in the foot writing a while loop or a for loop. And my own experience with multiple inheritance, and I've written some fairly complex code. At one point, a wrapper for socket classes, at a time when those wrappers weren't around for C++. Now, that is with multiple inheritance. Is while you just use it, would use multiple inheritance, there is no substitute can get with inheritance. There are a couple of ways that multiple inheritance gets used, and I show some examples, but we're getting more into the class is already larger than I anticipated it was going to be. So rather than the examples, what I contented myself to doing is to talking about why this is useful and then showing some basic examples. One common use of multiple inheritance involves something where you have, for example, you might have a method called print debug data. You want this print debug data method included in a bunch of classes across your design. And you say class, something like debug method. Define your debug methods and say class X. Class Y. Essentially, define your debug methods once, instead of having to redefine this code repeatedly in each of the classes that you're building. And this principle of define things once, so you can keep multiple copies of your logic in sync, is a really important principle for writing code that you can come back to and maintain. I cannot overstate the importance of the do it once principle, the final principle. And mix-ins are good. That's the most common use really in multiple inheritance in languages like C++ and Eiffel, which is the best C++, Java, C# language design for compiled languages I've seen, bar none. It unfortunately is something of an obscure language whose primary use is more in the European community. I support multiple inheritance in Unix. So inheritance works in Python is pretty the way I showed you. You say yes, and then classes that you want your class to inherit from. In parentheses, effectively as a constructor, add the name of the class that's getting code from different other classes, and go and on and on. Okay, so C classes primary superclasses, that first class, and an attribute called class.base can classes from which a class is inherited by looking. This is on 3. I don't know if what I'm saying is Python 2. By a method that is common to all classes called MRO. MRO or for method resolution. Okay. And you can class subclasses by invoking subclasses method. And here is an example those multiple inheritance and Python resolve resolution conflicts. Essentially, Python's, if you have a method A and a method B foo, the class multiple inheritance is if I invoke foo, which am I invoking? Python, like plus plus, uses the lexicographical ordering convention. You go left to right, and if you have a B dot foo and foo, the A dot foo shadows B dot foo. Okay. Further ado, let me ask you to copy and paste in the content of line 2001 through 2822. Up what's going on with my subclass. Run examples after that. Please tell me when you have this done, and I'll point what you should be looking for before we go on to what happens next.
Bill, we're ready.
Okay. So there are 4 methods in this called my subclass. My class is the top priority for method resolution. Just showing what I'm telling you is the truth. Yeah. Okay, for some crazy reason, to understand why Python is engineered this way, maybe MRO is a static method ultimately of object. All classes of object refer to objects MRO method. It's a class called jar. And my mason jar dot class dot MRO to find out my subclass's inherent hierarchy. If I create a class called candlestick, I'm choosing these class names because I'm looking around my mother-in-law's dining room right now as I'm doing this broadcast. My class called Birdcage, okay, and submit a subclass as a parameter for MRO. That particular invocation would tell me the priority. So for what I said, whenever Python goes to resolve an unqualified name, the first envelope is in for self dot whatever is in my subclass. If it's there, it goes up to name my class, and it's not there, it goes up to object. Now that's interesting because I don't see my Mixin class anywhere there. So I was expecting to see my Mixin class somewhere with my resolution order. Let's try see what happens if I say my main class. And find my main class. And then going on. Let's try it again. Fine, because I have an indentation here. Okay, that's looking better. Okay, select class and one of my subclass. Looking better now about what is I'm seeing. When it goes to resolve today, we'll first of all look in my subclass. If the name that will check in my name class. If the name is in final, we'll then check in Mixin 1, then Mix2, and finally go up to the top of the hierarchy and look at object. There are 4 local methods that collectively, these 3 superclasses of my subclass are defined 1, 2, 3, and 4. According to method resolution order, 1 should be class. 2, since thing called there's no method 2 in main class should be pulled in from Mixin 1. Since there's no 3 method pair in 1 or main should be pulled in from Mixin 2. And since we have an overlap of names in 1 and 2, we should be getting Mixin 1 instead of in 2. Right. Let me run from line 28 to 25 to line 2860, confirm what's going on, and please run when people run these. And again, once again, if people have any questions about them.
over here.
Okay. Questions? Sorry. Questions?
Yeah, no questions.
Okay. Okay, so and here next class learns type has a mechanism called property. Anybody ever do any of the old Visual Basic stuff in the Microsoft environment? No. Anybody code in Lisp? Okay, so out there. The idea of a property is convenience. Allows you to associate a gettable and settable value with an object, and you use expressions involving that object directly in assignment statements and directly in building up new expressions from sub-expressions. So, say property say property of food. Say if you use property in the right way, you can food the name food is stand in a getter, a setter, a deleter, and a setter. So you can invoke property in one place with keywords at fset, like fdoc. You can invoke positional parameters, and you can use things called property. Have examples that show the use of properties to when you have property isn't like I like to think of properties as kind of what bases give you with use special syntax to shortcut how you manipulate contents of the table, but here you're using special syntax to shortcut how you're manipulating values associated with the class. So I have a circle class, I have local value. If you define a variable in a class definition, that variable, that identifier, is essentially static to the class. Okay, and I property called a circumference diameter called radius. They're all essentially views of a single variable value. So, well, doesn't a single value. They're all views of the circle object state. And what I now do is set the circle by saying the circle has a radius, or the circle has a diameter, or the circle has a circumference, or the circle has an area. And then to these to get at the viewpoint, whatever the user sets up. Okay. So here's my circle. What I do is to make a copy of the code for class circle and running the different examples. Let's stop at line 2976. I'm sorry, after you read the code, after you copy the code, I'd like you to take a minute and read the code, because I think that especially in a conference call setup where I can't pictures easily, that the code does a better job of speaking for itself than I really can about word at hand.
We'll get over here.
Okay, a circle is an object that has 1 degree of freedom. And you set 1 degree of freedom in any one of a number of ways. My circle has a radius of this, my circle has an area of that, my circle has a circumference of the third thing, or my circle has an area. And it's fixed any one of those particular views of what a circle is. You define the other 4 useful views of a circle. And here, the idea of a property, a set of properties is as I see it, is very much, again, very much like what a database gives you whenever you can put up different views of a common table so the different users can see different aspects of what essentially is a single core entity. If I rewrote this class and called the class rectangle, then a rectangle would essentially be 2 degrees of freedom. And I have the constructor be 2 values to define the rectangle, and I might have a perimeter view, I might have an area view. However, one of the properties would be an incremental change rather than a total change to the rectangle. Okay. On the list I mentioned Visual Basic has languages to support this notion of properties. I mean, a fair amount of useful but the arcane properties of Python classes to this point, something like multiple inheritance with mixins doesn't use that much. Property stuff, to me, is a powerful feature of the language and one worth considering. Okay, so the first way of expressing properties with circles uses functionals. Essentially, the property functional. The second logic uses decorators. Okay. So what to do is to copy and paste. Feel free, but I'm not going to have you do that. I'm going to do it. what you do rather is to read how line 2947, which sets a radius property, with line 996, 331, 303, and is clear. My own preference between the two is with graders, because I think that something like line 2947 is a lot packed, aggressive, than draft out over 1, 2, 3, really 4 lines, because the party decorator is picking up the document string from the first line of the radius together. And it's about the two different constructs Python gives you for defining properties. Any questions?
For you'd want over the other.
You have to choose one over the other. Python gives you both. Whenever I'm doing coding, is take one doing things with it, and one way of doing the thing, try to stay with that way of doing the thing for consistency. A lot easier for someone else to read another person's code if you're doing a particular task, to just keep writing it in the same way, and do it one way one time, and the second way and the second time, and the third way a different time. So both those idioms are present. Any questions? Now we have some examples of working code here and some stuff further on down, but I would like to hit on one before I start and say I have some classes and some stuff with classes, so class subclasses. A getting at that are shadowed by other methods. These are class methods. You can text other forms stuff that is in your superclasses, and you can still invoke a superclass directly by name. So some examples to show you how to get around default inheritance conventions the language gives you. What I could do is to try copying out lines 78 through 3094 and try lines 3097 through 3107. I forget.
getting those same errors.
Yeah. Okay. So 30 to 3093. Sure. What is going on? You have to find. Should I? Should myself and then call it should set up in one should set value 2 and you should pull an instance value 1. So I'm not sure about what it is that's going on with my first example, especially since I believe that that example worked at one point. So I have some work to do for after the meeting concludes. If we pull case 1A temporarily, move on to case 1B, and move on to the case 2. Case I think will work. Case 1B is that the idea of subclass a built-in class using the superclass to do part of the initialization and then adding value. Here, the difference between my list and the build Python list, that I'm extending the build and Python list class an owner attribute, and this I believe will work. And the first example will work. I just need to figure out how to tweak it, and rather do that whenever people aren't sitting on their hands and me twisting the wind. So please lines 3111 to line 3124. See if this works, see if this makes sense, and ask if you have any questions, or let me know when you get that work.
Okay, this one.
Okay, let's see if it works any better. I think all of a sudden things became a lot more dramatic, right? I'm not sure this is going to work. That works. Oh.
Oh, that works for here.
Okay, it's good. Again, in other languages, well, I'm familiar with the C++ syntax for this. I'm guessing the Java and C# have something similar, where as part of setting up a subclass instance, you can defer to the superclass instances, where you get the superclasses to kick in, then get the superclasses to kick in. You finally close out with getting the subclass to kick in. So one since it's 4:53, that I think should be reasonably accessible, and review this next week. I should be back in Oak Ridge Wednesday after I get done taking care of some stuff for my mother from Pittsburgh. You can in Python customize, I think, all of the build operators. You can customize operators on a class-by-class basis. You change, for example, with less than, equal, not equal, greater than, equal, or greater than mean. You can overload the underscore names for the operators and a class definition and change what's going on. Matter of fact, it is critically important if you're in classes, at the least, to change definitions for equals and equals. Here, in Python definition is equals and equals, keys off of ID. Straight. So two circle objects ID value. Aim is a second circle object, then the two circles are considered to be equal. In effect, they're equal only if they are exactly the same object. The definition of equals that will typically want when they're working with a code. Typically, what's wanted is a weaker definition of equals, technically equivalence. You would, for example, if you have a circle object, typically want two circle objects to be equal if they have the diameter, or diameter within a tolerance of, say, 1,000th of an inch. Added a property to a circle where you have a circle object that has a color. You would want two circles to be equal if they have the same diameter within 1,000th of an inch, and if they're both same color. Okay? So whenever I write Python classes, what I tend to overdo is overload equals and double underscore not equals. And this example is a definition of relations that implemented in the language XSE. We have the notion of existential equality for contained objects, which proved to be somewhat useful and somewhat different from equality and from relations as you've seen them. What I'd like people to do is kind of a closing act for today. We'll get back to and what's going on with 1A and correct that. On people to come and think about it for a while and think on with example existential equality, where you have the various relational operators defining existentially.
Syntax examples that start at 3243.
Okay, what I'm doing is I am producing people whose elements are resultants, less than list 0, less than equal to is a list less than itself, is a list less than equal to itself, is a list equal to itself, is a list not dissimilar from itself, is a list greater than equal to itself, or is a list greater than itself, under this definition of existential equality that XSLT, the line T, implements. Does that make sense? So,
yes, that makes just doing it all at one time.
I'll do it one time for brevity. Okay, so think about this definition is that you say a comparison holds true if you pick anything out of the left side and pick anything out of the right hand side and get to compare. If you have list left and list right, and you say list left is not equal to list right if there's anything in list left that is not equal to something in list right. Similarly, if you have list left and a list right, you can say the two lists are equal if you have anything in list left that is equal to something in list right. Any consistent, not implemented if the type of the two things that are being compared is not correct. And it turns out that this definition of existential equality actually has some uses, and that's why that definition was implemented in the context of XSLT. And the point of particular exercise is to show that if you build yourself a class in Python, you can find how objects compare. You need definitions that are not what Python gives you as instance. Are there questions about this first existentialist example?
Questions over here.
Okay, I'm showing clause 3, and I have some homework here today, which really should work, but wasn't. I need to figure out why that wasn't working. What I tend to do is to close down the class at this point today. Thank everybody once again for showing up and for asking good questions. We put out for next week 1 through 8, where 8 is going to start showing some more examples of classes, go a little bit beyond the rudiments of the concepts and how they work. Any final questions before I close out my session?
No question.
Okay. So, Dwayne, Dave, anybody who's in the room, thanks for coming, and I will be there. If all go, I'll be there next week in person.
All right. Thank you.
Thank you.